So we're going to talk about how you can write an equation from a table. And the thing that's different today than what we've done in the past is in the past we've given you a specific type of table, either arithmetic or geometric or one that has a slope or has an intercept or one that doesn't. And today you're just going to be looking at tables. And you're going to have to make some decisions. So this first part of this flip chart is kind of the thinking process that you want to go through. Okay, so we're going to go through this first and then we'll apply it to a table. So the first thing you have to decide is, what's the pattern you're looking at? If you've got an addition or subtraction pattern, you're going to follow this pathway over here. Because remember, addition and subtraction patterns, those arithmetic sequences, those are going to be linear. And linear equations can be written in either slope-intercept form or point-slope form. Now, if you have a multiplication or division pattern, then you're going to follow this path over here. For multiplication or division, that's when you've got a geometric sequence. And when you have a geometric sequence, we can't write a linear equation. You have to use your explicit rule to do that. So that's the first decision you're going to make. Okay? If it's geometric, you've only got one option. Okay, that's your type of equation. If you have a linear equation, you actually have two choices. You can write your slope-intercept form or your point-slope form. And that's all going to be based on the information that you have here, whether you have a y-intercept or no y-intercept. So let me show you what we're talking about here. All right, so some questions to think about are listed down below each table here. But the first thing we're going to do is we have to figure out what our pattern is. So when I look at this side, I notice I have a +1 pattern. So automatically, if it's an addition pattern, I know that I'm talking about an arithmetic sequence, and it's going to be linear. And if it's linear, that means it's going to have a slope. So I need to figure out what that slope is by looking at both sides of my table. Okay. So now that I know my slope, what I'm going to do is I'm going to list my slope, my change in y, over my change in x. The next thing I want to look for is see, do I have a y-intercept or just a point? And if I look at this table, I know my y-intercept is a place where x equals 0. So my y-intercept here is going to be 2. Now if I didn't have a y-intercept, I could pick any other point. But knowing that I have a slope here and a y-intercept, that means I'm going to write this equation in slope-intercept form. If I had a point and a slope, I would use point-slope form. So then we just have to write our equation. So slope-intercept form is y equals mx plus b. My m, my slope, is 1/2. And my y-intercept, that b, is +2. Okay? Let's look at another table. We'll look at this one here. Again, start off looking for your pattern. When you look at your pattern here, I notice that's a ×3 pattern. ×3 means we've got a geometric sequence. If we have a geometric sequence, the only type of equation that we can write here is this explicit rule. Okay? And that explicit rule is going to have a start value and a change value. So again, let's start with our change. Our change is that pattern of ×3. Okay? Now the start value is a little bit tricky because again, your start value is where your x value equals 0. Okay, there is no place in this table where x equals 0, so I actually have to continue this pattern backwards a bit. And I can see that when x is 0, y would be 1, because then it would follow this ×3 pattern. So my start value, right up here, is going to be 1. So now, this equation, remember, this is the one that looks like y equals our start value, which is 1, times our change value, which is 3, and then our variable is going to be an x. And that x is going to be listed as an exponent. I'm going to change my colors here so you can see my start value was 1. My change is ×3, and my variable is an exponent x. Okay, so follow the flip chart or the flow chart on the front page, and just step by step you'll be able to do this.